Hi everyone, by now you should have completed your bell ringer. We're going to kind of go through it. If you were to find the perimeter, right, let's see if this will let me exit out. If you were to find the perimeter, you can count up the sides that are flat. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this side length right here is 20. The other flat side that we can count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what we're going to do is we're going to draw our triangles for the sides that we can't count. So I'm going to count over and up, right? And then I'm going to count over and up on the other side as well. And I'm going to see if they're equal to each other. I think they are, but I'm just going to count to be sure. So this is 1, 2, 3, 4, 5. Right? This side right here is 5. And then this other side is 1, 2, 3, 4, 5, 6. So I'm going to see if the other side's the same. 1, 2, 3, 4, 5. It is. 1, 2, 3, 4, 5, 6. So these two they happen to be congruent to each other. So whatever I find for this side, I'm also going to find for this side. Remember that the diagonal side that you're finding is C. C is a side. It is not 2 points. So I'm going to do 5 squared plus 6 squared is equal to C squared. 5 squared is 25. 6 squared is 36. That together is equal to C squared. 25 plus 36 is equal to 61. 61 is not a perfect square, nor does it simplify. So because we're finding the perimeter, you may have wanted to get this as a decimal. And 61 square rooted is approximately 7.8. Looks bad, 7.8. So the perimeter is adding all the sides together. So I'm going to do 7 perimeter is equal to 7.8 plus 7.8, right? Because we have two sides there, 7.8 plus a side that's 10 plus the other side that's 20. So we're going to add all that up. 10 plus 20 is 30. 7.8 plus 7.8 is 15.6. Add that to 30, and it looks like our perimeter is 45.6. And that should solve it. Okay, so you hopefully got that as the right answer. So today we're going to spend some time talking about slope. There are 4 types of slope, So you have a positive slope, and a positive slope tends to go, you always read it from left to right. The slope goes up, 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 up. It's increasing. Negative slope goes from left to right, decreasing. Zero slope, it does not rise, or it does not go up or down. Versus an undefined slope, it only rises and it does not run. It does not go side to side. Okay, so technically there's a 0 in the denominator. You need to know these types of slope because you could be asked what type of slope something has, and you're going to need this for next class's lesson. Okay, so I want us to know that when we are counting slope on the graph, you're going to start at the origin, meaning this point that you see in red, that is called the origin. And from the origin, you're going to count either up or down and so forth. So let's take a look at example 1. We're going to find the slope from a graph. Okay, so here goes example 1. When I'm finding the slope, I want to decide which points I'm going to use to start. So I think I'm going to start from here, okay? And then from this point right here, I'm going to go up and over until I can reach another point safely. And then I'm going to count this, because in order for me to find the slope through a graph, it's rise, right? How much I go up, over run, and run is how much I go side to side. So my rise is 1, 2, 3, and I go up, right? Up 3, and I go 2 over. So these are both positive. So my slope here is equal to 3 over 2, and I know that because from left to right, this is going positive, 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 is going up, 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 right? Versus if I look at this graph right here, from left to right, it's going like negative, 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 it's becoming more and more negative, right? So I'm expecting that my final answer is going to be negative. So same thing, I'm going to pick 2 points. I like this point right here, and it looks like the next point that I want to use is maybe this point right over here, right? I could do this point and that point, whichever way. I'm going to try and show you both ways, okay? So remember, it's rise, so I'm not rising. It looks like I'm going down 1, and then I'm going over. So when I go down, I go down 1, that down 1 is negative. And when I go over 3, that's in the positive direction, right? So my slope here is down 1 because that's my rise, right? It's my rise. And I go over 3. So my slope happens to be negative 1 over 3. Okay, so this is example 1 and example 2, how I would find slope from a graph. Another way that I can find slope is from an equation, especially if it's in slope-intercept form. So slope-intercept form is the y equals mx plus b form. M, whatever is attached to x, m is a number, and that number is slope. Slope does not include x. So your goal is to try and get equations into slope-intercept form. So let's take a look at example 3, and then we have example 4 and example 5. Okay, so in example 3, this is the example 3 right here. In example 3, I can see that something is already in y equals mx plus b form. So here's mx plus b. So what that tells me, that the number that is attached to x is m. So if m is equal to 5, then my slope is 5. Okay, if m is equal to 5, then my slope is 5. This one was easy because it's already in y equals mx plus b form. Look at the next example. This is not in y equals mx plus b form. And so what I want to do when it's not in y equals mx plus b form is I need to get it into y equals mx plus b form. So the very first thing that you're going to do is you're going to move the x term. I want to move the x term by doing the opposite. The opposite of positive 3x is minus 3x. So, and I'm going to minus 3x on this side. So now I'm left with a positive 2y, and then a minus 3x, and the 12 over here is also positive, right? So there's going to be a plus 12. From there, what I want to do, remember that your goal is to get y by itself. So I have to get rid of this 2. And the way that I get rid of this 2 is through division, because right now they're being multiplied. So that's going to cancel out. But what that means is on the other side, on the opposite side of the equal sign, I also want to divide everything by 2. So now I have y by itself. I'm going to leave the fraction how it looks. And 12 divided by 2 is 6. So now I have it in y equals mx plus b form. And of course, your slope is whatever is attached to x. So this part right here is your slope. So your slope is negative 3 halves. Okay, and that's what your slope is going to turn into. Our last example, if you take a look at it over here, is also not in y equals mx plus b. So I'm going to do the same exact thing. The first thing that I want to do is I want to move the x term by doing the opposite. So I want to minus 3x on this side so that it cancels out. these right here are not like terms, so you don't actually do 5 minus 3. You got to keep them separate. Remember, there's a minus 2 left behind, so this is minus 2y. I'm going to write the x term first. 5 is positive, so I'm going to leave it as a plus 5. Okay, similar to the previous problem, y is not by itself, right? Y has to be by itself, so I'm going to divide by a negative 2. So I can cancel that out, and everything gets divided by a negative 2, okay? Everything gets divided by a negative 2. So that leaves me with y equals, a negative divided by a negative is a positive, so it's going to give me positive 3/2 x, and then a positive divided by a negative is a negative, so negative 5/2. I have two fractions and it looks kind of funky, right? But remember that your slope is whatever is attached to x, right? Whatever is attached to x, just like over here. So my slope is just whatever is attached to x, meaning that your slope in this last example is positive 3/2. So the goal is, if something is not in y equals mx plus b form, to get it into y equals mx plus b form, because m is your slope. The last way to find slope is using your slope formula. So this is when you have 2 points. Sometimes you have 2 points on a graph, and you're going to be asked to use the slope formula for it. Other times you don't have a graph and you just have the points, okay? So you've seen this formula before, y2 minus y1 over x2 minus x1. This is the same as rise over run, right? Rise goes up and down, and run goes side to side. So let's do a couple of examples. So we have 2 examples, right? And then you're going to try these problems on your own. So let's say I want to find the slope. The very first thing you want to do is kind of what this Jamboard already does, is you want to call the first point x1, y1, and the second point x2, y2, because then you can use the formula that you're given here. So the key is to label. So m is equal to y2, which is 6, minus y1, right, which is 2, over, we're right here, x2, which happens to be 5, minus x1, which happens to be 3. And we're just going to do the math here. 6 minus 2 is 4. 5 minus 3 is 2. And this simplifies to 2, so your slope is actually 2. And if you were to graph this, this is the same as 2 over 1, because you need to know that this is your rise and this is your run. And since they're positive, rise goes up and run goes that way. Only if you had to graph it, okay? So do keep that in mind. Let's take a look at our last example. So I know that technically you could count your rise over run, but I want us to use the 2 points that we have here. Okay, so we have negative 3, 3. So I use some negatives just because the negatives mess us up. And then 3, negative 1, and we want to find the slope. Okay, so the very first thing you want to do is you want to label point 1, x1, y1, and point 2, x2, y2. So then you can use the formula. The formula says y2 minus y1, so I have negative 1 minus 3, over, and then the next part of the formula says x2 minus x1. So I'm going to do 3 minus a negative 3. It looks weird, right? But this is negative, so it's got to be minus a minus. So let's clean up our math a little bit. Negative 1 minus 3 is negative 4. And 3 minus a minus 3 actually turns into a plus. Isn't that interesting? So 3 plus 3 is 6, so I have negative 4 over 6. This actually reduces. These divide by 2. If you knew that. And so divided by 2, this gives us a negative 2 over 3, and that would be our slope. And then you can verify that with the graph, right? So these are the 3 different ways that you can actually find the slope. And now you're going to practice. You have practice problems that we did example 7. You have 10 practice problems where you are either identifying the slope from the graph, you're getting it from an equation, or you're getting it between 2 points. Make sure to show all your work. and we will see how you do. Thanks, guys.